And breathe.
In a final summary statement, so there's as little confusion as possible, this individual, that's myself, I don't believe in any of these theories, because I don't believe that you can have families of theories and jump between them to pick the one that works for the particular problem you're trying to solve, because that's inconsistency. And I don't like inconsistent theories, and these theories are inconsistent with each other. So I'm saying, and not only that, I've also described how we're going to show that none of them, they all require the Pauli exclusion principle to be true, and energy conservation requires that the Pauli exclusion principle not be true. And eventually I'm going to suggest that this new theory that was developed by Randy Mills, and I've kind of followed it in a slightly different, led to different conclusions than what Randy would suggest it leads to, but I believe I followed the theory without deviation and just allowed it to lead where it wants to, that this theory actually shows that in the helium atom, in the ground state, what we call the ground state, one electron is at minus 54.4 electron volts and one is at minus 24.6 at time 0. That is the ground state configuration of helium. 2 electrons at different energies and different sized bubbles of charge. They don't overlap, they are not the same. And what we're going to find is, remarkably, there's not a shred of data inconsistent with what the classical quantum mechanics predicts. That is, that there are 2 electrons in the ground state of helium which are not at the same energy. And this model is consistent with energy conservation. It's remarkable.